Let's start streaming, and it should connect in a second. Yep, we're live. That is absolutely awesome. Okay, we need to complete this. See how it looks? It's good. We need to complete this indexable enum array thingy. Mm, I've added this interesting function that takes in the predicate um, and basically returns an enum for which this predicate is true. Now the problem, we need to define that this predicate should be callable. Um, Although I think compiler handle this. But what's more pressing here is the fact that, well, enum like that might not exist. I don't know how to fix it yet. We should probably check. We should probably check for like, make sure that first of all, so enum type must be unsigned int type. Then enum type members must totally fill the range 0 to n, 0 to n minus 1 actually. Yeah, I mean, I guess there could be like, remember it's out of scope, it doesn't break logic here, but I don't think that's how I want it to work. So no enum type member can be out of scope 0 to n minus 1. Actually, maybe optionally erase size t parameter and hard code the size based on members, which is also like a possible thing to do, and I don't know how to do this. I have no clue how to do this. So we'll do what programmers do. Um, we'll use documentation actually, probably. Um, Wait a second. Yeah. So that's a requirement here. I've never done anything like that. Um, hmm. Hmm. Yeah, this is honestly, I don't know how to do this. So yeah, we can obviously check if it's enum. We can get underlying type. Oh, what is scoped enum? Wait a second. Wait a second. Provides the member constant values for the true scope enumeration. What the fuck is scope enumeration? Maybe that's what I need to do. What is scope enumeration? Oh, it's just enum class. That's what they mean. So we need to do is scoped enum. That will need to do underlying type of unit, and then we need to like I don't know, just not be branded, I guess. Okay, so I guess template. Mm, I've never done it before, so be patient. Okay, so requires. So I think this is something like that, right? It's like same, but we want to also something underline maybe. Yeah, man. I mean, so it is. If okay, let's try. Um, requires um, underlying type of enum type same. That is probably so inefficient. Um, but honestly, I don't know what is better. Mm. But this is conjunction of constraints is formed by using so it's basically like Boolean. It's basically Boolean algebra on the operators, right? And then we can do like this sounds this like is Fina. I thought this is pretty much dead, but yeah. Um, as is scope in yeah, bro. And it's supposed to work. Should I put like conjunctions? Um, and what I shouldn't put a. If this fires, bro, I'll be so surprised. Oh man, I fucking closed it. Okay, no. For this, let's try and this. Yeah, bro. Okay. I think this is the problem here, actually. So let's delete this and build it once more. No, it's just totally wrong, right? Um, concept. Oh yeah, and there is also here. Okay, what is that? What? Oh, because it has no. Wait, it worked then because those have like integers. No, those has I think just sorted type. Okay. Constraint also satisfies particular. So it's good. So the constraint works. Enum indexable array with enum type suits stored type enum utility enum indexable type. Okay, same as uh, okay. So it might be a possibility that I'm retarded. Um, just try this because this is true. But I want it to be. But this is true, bro. What? That's so weird. Indexable array. Indexable array. So it. Yeah, bro. Sure. Um, can I get like a list of concepts though? Like, I want really a list of concepts because I feel like there's this concept called same, right? Look at this, same, but they just don't use. Oh, example concept from the standard library. What the fuck? So where this is? Boolean same. Bro, I feel so retarded doing this. Okay, so it makes sense that it's value concept bool. Oh man. Example concept from the standard library ranges TS. Same. Can I use this concept though? What's your problem? What the fuck? I fucking ripped it out of the documentation. What do you mean don't permit, bro? What are you talking about? That's your code, man, not mine. Concept. ISA C++ doesn't permit bool keyword after concept. Oh, I guess. Guys, ISA C++ will come for you finally, you know. Same. Okay, will it work? Will it work now? No. Not great. Okay, I'm figuring it out slowly but surely. Okay, this is absolutely not that. I don't. Okay, question. Underlying type C++. Is it a const expression? It's not a const expression. But this is a const expression, right? It's not a, yeah, it's a const expression. Yeah, and I mean, yeah, we cooking. We cook, bro. We cook. We are cooking here. Yeah, man, we cooking here. Okay, now question is, can we go like, is unsigned C++? Is there like yes, there is actually. Is unsigned. It's a type trait. Is there a concept for that? Concept not working with unsigned integers. That doesn't sound. The concept unsigned integral is satisfied if and only if t integral type, and that is perfect, bro. So we do just do. Yeah, it's big brain time. We just do that, and bang, bang, bang. And are we Gucci? Are we Gucci here? Unsigned integral t is fine. Mercy. That's interesting. Actually, Bull can satisfy this. That's really interesting. So it's not exactly what we look for then, right? Because yeah, I mean characters on some platforms are actually signed and other unsigned. So it seems that we don't have a concept that is concept unsigned. Apart from this, I don't think there is a concept for that. Huh. What? Okay, but it's an unsigned integer, and I want to make sure that it's just an unsigned It's an unsigned integral type. I mean, I don't think anybody is going to be passing bools to that. I mean, can you even like define an enum over bool? You can't do that. I think like this is not possible, right? I mean, let's see. This won't compile, surely, right? Yeah, I mean, this doesn't compile because you have more than two. You have more than two members, so that makes perfect sense. Actually, okay, so we are getting somewhere. Mm, so we have pretty cool. We have pretty cool concept here. That ensures that this is actually. But also, what we need to do is ensure that an inner, right? Concept scoped inner. Well, okay, so it's a type trait, but I need the concept for it. Applied using class in as bit fields. Wait a second. Oh, okay, now, bro, yeah, you just turned off my brain. I wrote an article for a German magazine Xcode scope enums in C++. The survey shared an approach for using class enums as bit fields without the hassle of having to define operator for such operation. Operator? You can define operators for enums. I didn't know that. The approach was inspired by using enums classes as bit fields. Those are the same, so surprised things I'm telling you guys. I like tend to think that those same, but I don't think like I start to think that well underlying. Okay, let's see here. The permission is classed in making the code type safe. Now, all of you who once have dealt with enum classes know that they can come with support for operators. Well, as apparently, apparently yours truly didn't know that. Which also is their strength. You can define the desired operators for each enum. The issue here is that most code is the same. Cast in into the underlying type, apply the binary operation. Uh, hmm. I'm not sure what to think about it. Okay, so what he's doing here is enable it, and then he's making a conjunction value. So I guess conjunction is just and is enum, and then he's checking like if it's the same underlying type. As some wait, this is not underlying type. Um, declaration type enable bitmask operator or okay. So this basically says that okay, if boolean is same as oh man, this is boolean is the same as the so basically the passed-in type is a boolean, so it has an underlying boolean type from what I understand. An operator, and if this is true, define an operator using underlying as underlying type and or operator. That's really cool. That is really cool, my man. But this shouldn't pass, right? That's so true. Like so interesting. Like you see how much we learn. This is like an educational stream. I should probably switch to education here. education. You see, this is an educational stream. I'm educating the masses. Well, having said that, I think that well, but this is oh man, this is crazy to me. It requires yeah, I mean, he didn't come up with a better way to do this. Mm. Okay, so now we know that this is an enum and it is as an unsigned integer underneath it. That's wonderful. That's absolutely lovely. Okay, we are getting an underlying type here. Wait, but now we have this, right? So we can be smarter. Instead of doing that, we can do this, right? This compiles. Okay, so this is super cool, right? This is super great. But we still don't have this ensured. Like, I don't know how to ensure that this will not crash at some point in time. Because in my opinion, it will crash finally. Like, it will happen. Sooner than later, actually, I think it will happen. Imagine the kind of people that watch these streams, like, they come and this guy's just coding, like, some crazy concept. I mean, that's crazy, but, like, some concept in C++ in the what? Okay, so I don't think we can check this. I honestly don't know how to check this. Checking for the members of enum class in C++. Oh man. Is enum enum is C++ real world use case? What do you mean real world use case? It's like so obvious, bro. Like I swear, people who read things like that, they must not be able to think. Like real world use case of what of an enum? Like real world use case. I guess people who know how to solve this problem are like, oh, people that don't know it, they must not be able to think. Spinner check if in enum contains value. Oh wait, this is advanced. So advanced. So template. I'm not really familiar with templates like that. That's my problem. Template has bar enum value 0. Okay, but this checks. But this can be done then. Like I'm pretty sure this can be done in this case because this basically checks if an enum has this like name, right? But we are so close because we need to check if an enum has a value. So it's like pretty much the same thing now. Probably not. But this is really close. Okay, let's try and use Gemini for that. Okay, let's see what Gemini will tell us. I think that Gemini will basically tell us, well, you can't really do that because it's important. Wait. Well, we are waiting for it. Checking if C++ is dense, it has no gaps, and contains exactly values from 0 to 1 is notoriously difficult in standard C++ because the language lacks proper reflection. Yeah, that's true. C++26 might have a reflection. However, we can achieve this for an approach. It's depending on how strict you want to be. Yeah, I want to be extremely strict, right? Oh, hello. I'm building. Um, I'm building two programs actually. Right now, I'm building a server app for like a poker program, and this is actually right now I'm working on an enum indexable array, which is an array that you can index with an enum, right? Because normally you can really index an array with enum class, and currently I have written this concept that requires this parameter to be enum and to be unsigned integral type. And now I'm trying to figure out how to make it so that this enum is dense. And by dense, we mean that when we define an enum, it has no missing value. So it's always 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. It has no missing value, right? Because we want to iterate like through the whole array, and we want to know that each index of this array has a corresponding enum value. Yeah, I hope I make it clear. And I don't know how to write this concept, basically. That's why I'm asking Gemini for it. And Gemini tells me that it's hard. So yeah, it's a AI slope reading stream, I guess, right now. Cannot tell you how many times items in the enum or what their values are. Oh yeah, that's actually true. Yeah, so that's actually really good. So this one is used at Google. I saw this when I was working at Google. This one is just automatic at Google, and actually we have it here as a max value, right? So we can also like probably then make like member count and make it like 4. Well, it's accidental here. It's just and then make it 13. That's actually a really good solution that I should have thought of that. I'm stupid for not thinking about that. And how they are checking that? Verify underlying type is unsigned. I have this done. This is where is it? So we are checking that it's enum. We are checking that it's unsigned integral. By the way, this can be also a Boolean type, but nobody will be making an enum based on Boolean. I mean, that doesn't sound correct. I mean, you can do that, but it will throw an error if you do that. In this, probably it will throw an error because you're. I don't know if it will. If it will. If you define an array with like only 2 members, it won't. I guess. I mean, enum of just 2 members, and now we can type. Okay, so it requires to have this count, right? It's okay, I guess. And this is constructor. Well, I don't really want to construct using a constructor though. Okay, where I can do this is I actually need this data only here. So instead of constructor, I can do this here and enum type, and this is called K. They call it one more time. Member count. Member count. There's like oh yeah, there's message. Well, so I guess it's like kind of a loose constraint here. It's not a perfect solution to the problem because still some dumbass can call it enum that's not compliant with the standard here. So we will read the next solution from the GPT. I mean, from the Gemini in a second. Okay, next solution. Requirement on the enum. Well, it's obvious. Magic enum library, the perfect what? No, bro, we're not doing that then. Okay. And the third, C++. Well, there is a concept for that. What? If you want to keep it simple, just ensure the static cast inside your function won't truncate data. I don't think he understood the assignment here. Yeah, he didn't understand the assignment. But this is this kind of a fix. I mean, it can still break a function, but yeah, I mean, it works. So this is really cool because this function, basically what this function does, it returns you an enum value for which this predicate is true. So how I use it? When I check, for example, for the flush, right? If you don't know what flush is, a flush in poker is a hand that contains 5 cards of all the same suit, not all of consequential, not all of sequential rank. So, and actually, this is a royal flush because they are sequential. But so, let's say that this is a hand. So we are taking the suit count mapping, and the suit count mapping is enum indexable array. That is, we supply it with a suit as the enum that we'll be indexing with. We supply it with a U8 as a type that will be actually stored in the array, and then we supply it with 4 as a size. And then we check here. We get this array. We use return enum4. We pass the value because it will be checking each value in the underlying array, right? And we check if the value is 5. If yes, then it will return an optional that actually stores the value in it, so it has a value. So it's true. We found this suit that satisfies this, and we return a combination type flush. I think that's pretty neat because actually this is so usable. I use this in like 3 places already for flash, for full for here. I use it for straight flash. So straight flash is basically sequential, 5 sequential. I think those are straight flash contains cards of the same suit. Oh wait. No, it doesn't contain cards. So it's wrong, right? Straight flash contains cards of the same suit? I don't think so. Yeah, the same suit and they are sequential. But the straight flash contains sequential cards of the same suit. Not those cards. This is a real flash. So again, we are checking if there are more than 4 cards of some suit. And then if there aren't, so basically this returns a null option, we return this false and empty. Well, it doesn't really matter because it's empty, because it's false, right? So it doesn't matter what this value is here. And then we filter it with ranges to only contain this suit. And afterwards we iterate to see if it's consecutive. Since the hand is passed in as a sorted thing, as a sorted collection, we are sure that we can just iterate like that. Because I sorted the hand set beforehand. Yeah, that's what I'm working at right now. What do you think about it? Yeah, actually, I'm pretty proud of that. It's let's see if it works actually, because oh wait, there's a it's a warning. It's a warning. It's a warning. Not handled in the switch. Oh, how to say that? It's like excluded because it will show me. Cable? What does cable mean? Oh, cool. Thanks, man. Yeah, I checked it online and like. So yeah, now he's shouting at me like, "Oh, you are not checking every function, um, every possible value of the enum." But like, yeah, I can never satisfy those damn warnings, I guess. Now, let's construct a flash card actually. So flash is non-consecutive and 5, and see that it actually works. So let's take like 5 cards. It's king. Let's like 2. K10. K jack, and let's say K5. So it's not consecutive, but they're of the same suit. We pack those. This is sorted vector, also like the structure that I told you about. It's a sorted thing, and then we pass this with underlying here is a vector again, and we pass this as a span actually to the evaluator, and this should print out combination type as a integer. Integer rate actually can do this and u integer rate, and then flash is 4, right? So we should have 4 here printed out. Yeah, let's go. Let's go. It works. So yeah, that's really cool. That's actually really cool. That's massive. As is, I love this. I love it, man. As is a cool piece of code here. I should probably comment like what this actually does. So yeah. So it's a pretty specialized structure, right? I'm aware of that. Um, but I really think it's better than just using an ordered unordered map, because an ordered map is sparsely allocated, it's dynamically allocated, it's sparsely allocated, so it tracks your cache. It allocates, so it calls malloc probably, which is also unhealthy. And this enum indexable can be statically allocated on the stack because we are using an array with an previously known size. It's cache friendly because it's an array. So I just believe it's a superior option to using an ordered map. And if this is what I need to make it work, also I have this great function. It's like super useful. I mean, what it is, man. Now I have to refactor also usage of this, because now I'm also using here rank count. And if you look at rank here, it has how many? 13 values. That's so unfortunate. But it bounced. Oh, well. Okay, let's see. Now, this is actually used somewhere. Oh yeah, actually it's used a lot. Okay, so first of all, we need to clear it first. Okay, then we are, as you can see, then we are iterating through the hand that is dealt. That is also a span, which is also sequential. I mean, contagious in the memory. We are kind of collecting the data about it, and then where this is used again. Four of a kind, right? So we are checking if there is. So this is actually another perfect use of my function, of this function, because we are checking if there is any rank that appears 4 times in our hand, right? So we can again do just rank count mapping, return enum4. Now we can just write a predicate for that. It takes you 8 and returns if value. Oh yeah, is equal to 4. And now it's a counts the optional model card rank. I should probably at this point potential rank. And, yeah, rank. Well, I don't have to do that actually, right? I can just do. You see, that is a cool function. What's your problem? Oh yeah, we need to do has value here. Yeah, you see, that's a cool function. It basically eliminates a class code for us because it's well written. I'm so proud of this function. Holy shit. Again, this is the same thing as you can see. This is like pretty much the same thing. Well, not really the same thing here. Free of a kind, right? So we are checking if any of the value is free. If we have free on our hand. Yeah, this is the same use case. If any value appears 3 times. It will check if any value, if only like first rank appears 3 times, because it's possible in the Texas Hold'em version that when you have 7 cards, you can have two free kinds, technically. Obviously, there is no such combination as two times free of a kind, but technically you can have two triplets. But the code for, but in a situation that we will have that we will have a tie, so we will have two players and both of those players have free of a kind, I will write a separate code that distinguishes that, because I believe it's fast, because I believe that's not that often that it happens. So we will need this code later probably, and I don't want to pack this code here because it will slow down the evaluation process. So I will only how do you call it, resolve ties if it's absolutely needed to later in code. The same here, to check if there are two pairs. That's actually interesting because we need to call this function twice here probably, but we can call it twice. So how do we do this? Oh, I have an idea. Rank 1, let's say. Okay, now if there is okay, so it will return us the first rank that was seen 2 times, right? But we need to check if there is another. So we'll write a second check for rank 2 that will contain in it. Oh yeah, I guess we can do if rank 1, if it doesn't have a value, we can just return with false and the default initialization. But if it has value, we'll just pass it in here. And then, what's your problem? What's your problem? Expected. What? Ah. I will just show. Actually, you can then just cast it to. Oh, I see what was the mistake then. That's what I was. If value equals to rank 1. Well, what's your problem again? Statement should be inside braces. Like, if you know this, then maybe you can apply those braces. Can we, please? Okay. Okay, potential, if it doesn't have value, return false. Okay. I mean, is there a way to do this better? That's a pretty poorly written code, I'm not gonna lie. Const standard optional model rank. Okay, so first we check if there is pair, then if there isn't a pair we return, if there is a pair we go. So first pair rank. We pass in first pair rank here, and then we check if there is. We are omitting the first pair rank, and then we are. So this will ensure that we will not count the same thing twice, and we are returning true. Okay, and now what we need to do is. What is this doing? Oh yeah. What we need to do is return rank to his value. So actually, instead of this, we can just do it like that. That makes more sense. So yeah, check if there is at least one pair. Return if there isn't one pair. There is not at least one pair. At least one pair. Try to find another pair of a different rank. Pair. Since the pair of since rank of the first pair should be omitted. Okay, I think that's a lot better. And this is really simple. We just return this. Okay, this is built. Yeah, man, that is a cool code I've written here. That's a really cool code I've written here. Well, it's low cache pollution because we're using an array, so it has high cache speciality, right? Um, let's say that you would be normally. I mean, the first like intuition for that would be to use another map, right? That would store basically something like that, right? I've just been refactoring this, so you could like match map suit to U8 to unassigned J8, right? But this has a problem because another map is dynamically allocated and it's sparse. So by accessing a singular bucket of another array or another map, you would pull a lot of data, irrelevant data into cache. And let's say that you are using this when you're iterating through this. mm, you're just pulling in the array. I mean, obviously we pull other data, but it's it's just better for cache, I think. Uh, wouldn't you agree? Maybe I'll give you more light how I use it. I use it mainly to count things. So this is a poker evaluation. So this class evaluates a poker hand, right? So you're passing in the hand here, and the first thing that we are doing is counting how many on our hand, for each suit we are counting how many times it appears, and for each rank we also count how many times it appears because it helps with evaluation of like rank, of like flash and for the kind, etc., etc. So this is really helpful for us because then we can just iterate through this very easily. And what's the main strength of this data structure is this function that basically checks. Let's say that you want to return that, an enum for which the value in the array is 4, right? So you would pass a predicate like that. I think it's best to just show you an example. Let's say that you want to check 4 of a kind, right? 4 of a kind basically says we have, for example, 4 queens on our hand, right? 4 queens. So you would do something like that. Rank count mapping. Rank is for queens, right? Return enum for such value that is for a value that is 4, right? So if you count that there is 4 queens in your hand, and if you count that there is 4 queens in your hand, um, rank count mapping of k queen will be equal to 4, right? And this basically returns you that okay, this is satisfied for queens, and it's an optional because it might not be satisfied. So if it's not satisfied, it will be just annulled. Yeah, that's something I just finished, and I'm pretty proud of this because it works. And this is a beefy concept here. I need to extract this to a new file, but I don't know. I'm kind of hesitant about doing it. Why am I using this? Oh, what have I done? Oh, holy. Oh, man. In real life? No, we aren't. Uh, oh, we are alive. That's lovely. Um, what I was doing? Oh, I want to check this. Yeah. Um, yeah, we don't need it here. Yeah, I guess I'll trust this guy. Oh, okay. That'll be it for today, which is pretty cool. We'll see you tomorrow probably. Yeah, goodbye. Peace.